Everybody, my name is Aaron McEwen. I'm a solutions architect here at Catalogic Software. And also on the call with me today is Dario Trancatella from Classics. Dario is a technical advisor at Classics. And also on the call with us is Martin Fan. Martin is our field CTO at Catalogic Software. And today what we're going to be covering specifically is how Namespace as a service enables self-service Kubernetes recovery. So if you do have any questions along the way for either Martin or Dario, please feel free to chime in. We're going to go through the presentation, and then Dario and Martin are also going to go through a couple of quick demos. So again, if you do have any questions along the way, feel free to throw those up in the chat. I'll also post a couple helpful links in the chat as well for reference. And then at the end, we'll kick off a short couple question survey, and anybody that does fill that out will be eligible for the $100 gift card. But appreciate everybody joining today. And with that being said, Dario, I'll turn it over to you. Thanks.
Yeah, thanks a lot, and nice to see you all. So my name is Dario, and I'm here talking about multi-tenancy. So, but before proceeding, I want to introduce you briefly what we're doing at Classics. So Classics is one of the company that is working on the multi-tenancy area in Kubernetes. So by multi-tenancy, we are referring to an architectural pattern that you can use to address several challenges you're gonna face with your Kubernetes cluster. We are the creators of several open source projects. The most popular ones are Capsule and Kamaji. And right now we are going to introduce you what is Capsule. But before proceeding, let's try to understand what is multi-tenancy. As I said before, it's a pattern that you can use to create a sort of slice of your Kubernetes cluster. You know that with Kubernetes, essentially, we can spin up applications, and these applications are going to live inside a concept of the namespace. So a namespace is a sort of slice of your cluster where you can deploy your applications and all your components. But obviously, it brings some challenges, also because we all know that the pods, they need to run on a specific node to consume CPU and memory. And it's really challenging because it's like having a set of apartments. So you got a building and you got multiple tenants, and each tenant is requiring one or more apartments. So it means that also for your Kubernetes cluster, you have to choose wisely the resource location. So it means that you need to enforce your resource control. And also you have to address also some security and isolation challenges. But although these challenges could look like very cumbersome, keep in mind that multi-tenancy is bringing a lot of benefits, obviously, if you're addressing that in the right way. So since we're talking about Kubernetes, let's talk with analogies about buildings, apartments, and so on and so forth, and try to understand more how can we tame the multi-tenancy in Kubernetes. So we know that essentially with Kubernetes, we are using kubectl. So we got operators, real people that is using our Kubernetes cluster, but we all know that also we could have machine accounts, so the service accounts. And then once we identify the users, obviously it means that these users, they need to consume some resources. And these resources can be the Kubernetes API objects. So you can imagine the pods, deployments, ingress class, storage classes, but also you have to target also the OS resources like the CPU and memory. For example, you can say this tenant can consume just 10, 20, or whatever you want, virtual CPUs or many amount of gigabytes of memory. And then also you have to create a sort of partitioning in regards to the storage and also the network. And keep in mind that list here is really, really long, also because there are multiple shades of multi-tenancy, because in the end, it means that we got one cluster, one or more clustering bands also on your use case that's going to be used by multiple tenants, so multiple users, and you have to create a sort of quality of service. You have to create a sort of policies and rules to tame all the users that are using your Kubernetes cluster. Keep in mind that I already mentioned you that we got namespaces. So the namespace is the basic primitive API that we can have on Kubernetes, and it's a logical partition of our workloads. So I'm going to create my namespace, and in that namespace, I can deploy my applications. my applications like pods or daemon sets, stateful set, and obviously these applications are going to consume also some storage. Since we were talking about multi-tenancy, we could say, okay, we got namespaces, we got everything what we need to address that on Kubernetes. Well, yes, but actually no, because unfortunately, we don't have the concept of tenant. And with concept of tenant, we are going to see that I'm referring to the concept of grouping together some namespaces. But keep in mind that with Capsule, and also thanks to Kubernetes, we have all the API primitives to build our stronger multi-tenancy solution that is trying to address the basic concept of namespaces. So in this slide, we see that essentially we were able to identify the users, and now we have to talk about resources. And in regards to multi-tenancy, when we talk about resources, we got two items. So the resource control and the resource isolation. How can we control the resources? Essentially, keep in mind that most of the latest Kubernetes versions, they are offering two API types, the resource quota and the limit range. With the resource quota, what I can do is to say, in this namespace, you cannot consume more than 20 virtual CPUs or 20 gigabytes of memory. And with limit range, we are gonna to set some default values and also some limits for the workloads. Because keep in mind that Kubernetes essentially is like a Swiss knife. You can do a lot of stuff. It's not so much opinionated, so it can be used in many several ways to address your needs. But you can imagine that I got my application, and what happens if I deploy my application with no CPU limit or memory limit? That application can consume all the nodes resources. So with the limit range, we can say if you're launching a pod, so a workload, and you're not specifying a CPU and memory, by default, Kubernetes is going to apply those limits on your behalf. Or maybe you can say all the workloads in this namespace cannot have more than 20 gigabytes of memory, because maybe the workload is going to be placed in a node where I have 28 or 32 gigabytes of memory, and I want to avoid having just one node allocated with one workload. That was about resource control. Let's talk about resource isolation. So we know that with namespaces, we can group together our workloads, but obviously we have to pay carefully attention also about security. And how can we do that? Essentially with RBAC. With the RBAC, we can limit the access of the tenant owners to the API server, the Kubernetes API server. So it means that the tenant owner inside its own namespace can manage just the resources of that namespace. And this is really good because you can imagine what could happen having a sort of passepartout. So all the keys that are opening all the doors in your Kubernetes cluster try to translate the apartment to the namespace. So with RBAC, essentially you're limiting the user just to grant privileges on their own resources, on their own namespaces. Then you can have also network policies that are pretty important to avoid also denial of service inside of your Kubernetes cluster. So the applications cannot communicate each other if they are not part of the same namespace or part of the same tenant, we're going to see. Then we got also pod security, because Kubernetes essentially is allowing to run in a software-defined way a lot of workloads. So it means that I could have on a specific node one pod from a tenant and another pod from another tenant. And what happens if one pod starts a privilege escalation? It could read the data of the node and starting a privilege escalation and reading the secrets of the other application and so on and so forth, or compromising the Kubernetes API server. So with pod security, essentially, you are enforcing to limit the capabilities of the pods running on that node and belonging to a namespace. And then last but not least, what you can do is also to limit the network with a node selector. So it's a pattern that we saw several times. So it means that each tenant is bringing their own nodes, and all the workloads from that tenant are going to be placed just on those nodes. So with that said, we have everything to build our multi-tenant platform Kubernetes? Well, yes, but actually no, because we have to present Capsule also, because that's the topic, one of the topic of this presentation. So Capsule, keep in mind that it's an open source project that is backed by Classics. We are donating that to the CNCF, the Cloud Native Computing Foundation, and essentially Capsule is introducing a new abstraction that is named tenant. And with tenant, we are referring to a set of namespaces where a set of rules and policies are enforced. So essentially, we deployed this policy engine that is reading the manifest of the tenant YAML. So with Capsule, you are declaring the tenant boundaries. So you can say this tenant cannot consume more than these CPUs, and it must run these specific container images. All the workloads must run on a specific node pool, and Capsule policy engine constantly reconcile the required Kubernetes API primitives to address the multi-tenancy, and then is denying or allowing a set of rules. Because in the end, keep in mind that multi-tenancy is not just a matter of infrastructure component, but it's also about security. And that's the reason why we got this policy engine. So in a nutshell, with Capsule, you define in a declarative way that is GitOps compliant the tenant abstraction, so the tenant owners can create on their own the namespaces. So we got security, we got subservice, and we got also resource optimization, especially in Europe, where we are trying to save a lot of resources. It's really, really convenient. So I'll try to go briefly about these topics because I want to show you also a demo. So Capsule is able to work on any compliant Kubernetes cluster. So it works on-prem, it works on EKS, AKS, GKE, and essentially with Capsule, we are just intercepting the requests that are made by tenant owners. So the users must be authorized and authenticated to access the API server, and we're supporting certificates or bearer tokens, so service account, OIDC, or specific token. And after that, we are using another feature that is offered by Kubernetes by default. So long time ago, I don't remember, because release life cycle of Kubernetes is pretty mad. Although right now we are in a good shape. By the way, we are using the dynamic admission controllers, so we are using the mutating and validating webhooks. And these are nice features because essentially we are creating a sort of framework, a configurable framework to address multi-tenancy, thanks to the policy engine. And last but not least, we are going to use also the owner reference. So with the owner, we are able to create a sort of hierarchical tree about the resources. So the tenant definition is living at the cluster scope. So the platform administrator onboards the tenant, and the tenant owners, thanks to the definition of the tenant, they can create their own namespaces. And these namespaces are going to be binded to the tenant thanks to the owner reference. And this is really cool because we are getting for free the reconciliation of the resources that we have to replicate across all the namespaces. And also we are getting also the cascading deletion. So if you delete the tenant, all the namespaces are going to be deleted automatically. And last but not least, also we have to talk about CRDs. So CRDs is a huge topic, but keep in mind that it's a tool, or rather a feature offered by Kubernetes to extend their own capabilities. So it means that we are serving a new API type. So it means that can be installed without recompiling Kubernetes itself, and we importing the tenant definition. So keep in mind that this is the user experience for Capsule. So you can use the CLI, but keep in mind that Capsule is able to interact with any Kubernetes dashboard because it's totally transparent, because we are attaching Capsule to the API server. So it works for managed Kubernetes services, or it works also for installation that you did on your own, where you are controlling the control plane. And essentially, you create your own namespace, in this case, Bob, and Bob namespace is going to be attached to the tenant. And this is in a nutshell also the tenant definition. Keep in mind that I said before that this tenant definition is a resource that is living at the cluster scope level. So it means that we got multiple personas here because we got the cluster administrator, that is the one that is provisioning the tenant. And then we got the tenant owners, Bob in this case, that is going to consume the namespace belonging to that tenant. So it means that Bob can create their own namespaces. And with the tenant definition, keep in mind that there are plenty of shades of multi-tenancy. We got a website that is containing a set of tutorials, and the website is Capsule Classics.io, and there you can find a lot of recipes. But keep in mind that you can isolate the resources as well as you can control the resources. And last but not least, also there is the Capsule configuration, where you can configure Capsule, because Capsule is a framework to address your own multi-tenancy according to your needs. But let's stop this chit chat about Capsule and let's see if we can have a demo. So right now, I'm using this cluster. So it's a Kubernetes in Docker cluster, but keep in mind that Capsule is able to work everywhere. And we got also a set of namespaces because Capsule has been installed. So we got our namespace Capsule system that is containing the policy engine, the controller manager, the Capsule proxy, and so on and so forth. Now, what I need to do is to create a fake user. So I'm entering in Documents, Classics, Capsule, Tag, and I'm going to create a user like Alice belonging to the tenant oil. And as you can see here, this helper utility created me this kubeconfig. So what I have to do is to export, and I can try to test the connection. So kubectl version, and here I am. So I'm connecting to the cluster. And the first thing I have to issue is to say, kubectl, how can I create namespace? And the answer is yes, because Alice is part of the tenant owners, and she or he is able to create their own namespaces. So what I have to do is to issue kubectl create namespace oil development. But the answer from Capsule is, I'm sorry, Alice, you don't have any tenant. So we need another actor, another persona here. And this time in this pane, I'm the cluster administrator. And what I have to do is to create a tenant. Keep in mind that we try to design the same developer experience, user experience you could face on your own cluster, because in the past, if you want to have your own cluster, you need, well, your workloads to be placed in a Kubernetes cluster, you had to overcome some limitations of Kubernetes. And in the end, you were getting your own cluster, but managing multiple clusters is really painful. So you can imagine if I had hundreds or thousands of tenants, you have to manage 100 or thousands of Kubernetes clusters, and it's really painful because I've been a site reliability engineer, so I know the pain in managing a lot of Kubernetes clusters. So instead here, what I'm gonna do is to have just my portion of the cluster without stepping each other toes, because each tenant is going to be granted just with specific permissions on their own namespaces. So now what I have to do as a cluster administrator is issue cat eof kubectl apply menu set, and I'm going to write the Capsule Classics.io v1 beta2 tenant definition, and I'm going to create the oil tenant, and I'm going to define the owners. As I said before, we are supporting user groups, service accounts. We know that Alice is a user, and we have to define the name Alice. And here we are. So we got our tenant. So what I have to issue now is kubectl get TNT tenant. You know, it's a joke. And as you can see here, we got oil in status active with 0 namespace. Now I can watch for the events of this tenant. And right now I can try to create again my namespace oil development. And as you can see here, since we got the tenant, the namespace creation succeed. And in the tenant definition, we see that we got a bump up about the namespace count. Why that? Because if I issue kubectl get tenant, oil minus o YAML, you can see here that in the status, we got a list of namespaces and we got oil development. So far, so good, I'd say. And now what I can do is to create multiple namespaces like QA and then production. And if I issue again the get of the tenant oil minus o YAML, you can see here that all our namespaces have been added to the tenant, and automatically capture is granting the permission on these namespaces thanks to these cluster rules. In fact, if I issue kubectl minus n oil development, kubectl development get role binding, you see here that we got some role bindings. So it means that we are granted of admin and namespace deletion rights on this namespace. This is done by capsule. And keep in mind that if somebody is trying to remove these resources, automatically capsule is reconcile everything because it's an operator. The operator is automating all the dull tasks. So you can focus on other stuff, something like the reliability of your infrastructure and so on and so forth. Last but not least, also keep in mind that one other limitation that is really challenging in regards to multi-tenancy and Kubernetes is that since I'm Alice here, if I issue kubectl get namespace, it doesn't work. Why that? Because the API server, the Kubernetes API server is not ACL aware. So we can get just list of all the namespaces, not like any multi-tenant application with database, like select all the namespaces where the owner is Alice. It's not going to work like that, Kubernetes. And it's a huge limitation. But with Capsule, we were able also to overcome that thanks to an add-on that is named Capsule Proxy. So keep in mind that right now Capsule Proxy has been installed on this cluster, and I need to forward my traffic through the Capsule Proxy. And I have to get the secret where the Capsule Proxy certificate has been deployed. So it should be this one. It's correct. I'm going to copy that because right now I'm going to forward my request through the Capsule Proxy rather than the Kubernetes API server. So now I can issue kubectl capsule system SVC capsule proxy port 9001. Capsule system port forward SVC capsule proxy. Now what I have to do is to edit my kubectl because I don't have to use the original API server or kubectl. And also I have to change the certificate authority because I have to use the capsule proxy one. Keep in mind, this is pretty advanced and I'm doing that in real time. So fingers crossed, let's press the demo God and it should work. So kubectl version. And if we are lucky enough, we see here that we got our handling connection. It works. So famous last words, kubectl get namespaces for the capsule proxy. And as you can see here, Alice is getting just their own list of namespaces. And this is really cool because in the end, you can avoid having multiple Kubernetes clusters. So you can use one huge cluster for all your tenants and using the recipes offered by the Capsule documentation website to create your own multi-tenancy solution. But keep in mind that that's not enough because obviously with Capsule, you can address security purposes. You can address also resource optimization. You can tame essentially the cluster sprawl phenomenon. But after that, we got multiple challenges. And I'm referring to what happens if Alice would like to get just their own metrics. So we need to introduce the concept of multi-tenant metrics. And the same applies also for logs. I want to see just my application logs. But the most important thing in a Kubernetes cluster is the data. So how can I create a backup of my applications in a multi-tenant environment without the risk of overwriting the data of another tenant. And luckily, we are ending up with this collaboration between Capsule and Cloud Casa, and I pass the word to Martin. So I stop sharing my screen if I'm able. Oh, yes, done. So Martin, the screen is yours.
Good. Thank you so much, Dario, for that introduction into multi-tenancy with Kubernetes. And a great segue, I must add. So for me as well. By the way, can you all see my screen here? Just quick screen check.
Yep,
Here.
looks good, Martin.
All right. That was a great segue into Cloud Casa and backup, right? Because now, as we're having these multi-tenant Kubernetes platforms, we're going to need to ensure that our backups and restores are not stepping over one another, and integration within this classic capsule module is going to be of utmost importance to Cloud Casa itself. So if you haven't attended our previous webinars here, just to give you a brief overview of what Cloud Casa is, we designed Cloud Casa as a backup as a service application. So it is built by Kubernetes or in Kubernetes for Kubernetes, so it lives in the cloud. And you're going to be able to back up those Kubernetes and cloud native resources using Cloud Casa software as a service-based platform. Now, this is going to have both the software and storage included. There's no need to bring your own infrastructure as you're performing backups. It's going to be backing up to our object level storage, but you're also going to be able to back up to your own storage, object storage as well that you provision. Cloud Casa is a freemium product, so there are it's free up to a certain capacity. We recently introduced Cloud Casa for Valera, which is based off of the worker node or the number of worker nodes that you have out there in your environment, and an excellent use case of that consolidation of worker nodes that Dario was talking about, right? From a cost-based perspective, the less number of worker nodes that you have, you're going to be paying less for the backup products and the products that manage your Kubernetes platforms based off of the count of worker nodes. But what it's going to do is it's going to integrate into your Kubernetes applications, your on-prem Kubernetes resources and infrastructure, those resources based in the cloud, either through managed Kubernetes services like EKS, AKS, Google, etc., but also other cloud managed services as well. And what we're going to provide in terms of backup and recovery is this cross-cluster and cross-cloud mobility, right? So we don't really care about the underlying infrastructure architecture that you have out there, number of worker nodes, accounts, because what we're going to be able to do is we're going to be able to back up and protect those Kubernetes resources and the elements and resources within the pods and the namespaces that you have out there, and then be able to do a full stack recovery of those resources into a new cluster or an existing cluster. So we can spin up an entire new cluster on the fly, something that we call any to cloud or full stack recovery for that cross cloud and cross cluster mobility. And the way it works is pretty simple, right? You have the Cloud Casa platform living up here in the cloud on Amazon or Azure. We're going to have storage up there. And over here on the left-hand side, you're going to have your Kubernetes infrastructure on-prem in the cloud, right? We're going to snapshot, protect, back up those resources. We can do in-place CSI snapshots. We can migrate that data to our Cloud Casa platform, to our object storage in the cloud, which either exists in Amazon or Azure. But again, you can also bring your own storage, right? And as long as it's scanned in and registered to our Cloud Casa platform, you're going to be able to set that as a backup target for your Kubernetes-based backups. But where it gets interesting and where the integration comes in with Classics and Capsule is through the RBAC functionality that is native and built into Cloud Casa. So we're able to define users and user groups that have access to let's say a certain number of resources, storage resources, cluster resources, cloud resources. And it's through these groups that you're going to be able to find control of what each user is able to do with those resources from a backup or restore perspective. But that is only available at the cluster level, and that Class 6 capsule integration is going to give us that lower level granularity down to the namespace level, and which is going to be important, especially if you are doing namespace as a service. So my apologies, I skipped ahead here. So what this all looks like is from a cloud Kafka perspective, and this is a screenshot mainly based on if you're using Valero as your backup today, right? You're probably managing multiple Valero instances. Remember, each of those Valero instances are going to be siloed, so they're not going to be talking to one another. But with Cloud Casa, what you're going to be able to do is create an umbrella, a point of control, a single pane of glass that communicates to all those Kubernetes clusters and is now able to perform that catalog, monitoring, management, recovery, and support across all the clusters in that environment. But remember, it is only down to the cluster level. So Cloud Casa only knows about the cluster, and it's through Class 6 and Capsule that we're going to be able to see these resources at a namespace and restrict users based off of the tenant restrictions provided to us by Capsule. So that's one of the important features that we need to take into account when considering, this multi-infrastructure or multi-worker cluster Kubernetes infrastructure, right? Is that Kubernetes itself, as I explained, lacks that native multi-tenancy, right? And if you need to spin up a service or an application, right, that you don't want other users using or backing up or even restoring, you're going to want to spin that up into another cluster, right? And so then you're managing another Valero instance in that cluster. You're managing a whole separate cluster. If you're hosting your clusters in the cloud, your cloud spend, your compute spend is going to go up by thousands of dollars a month, let's say, before you know it, right? So what you can do is start consolidating this down, these clusters down, creating that level of isolation through capsule tenancies and grouping namespaces together on a per user basis. Each user having access and the ability to create their own resources within their own specific namespaces, and how that works in the back end with Cloud Casa is that these capsule tenants that Dario had referred to which users will be assigned, these will be mapped to a Cloud Casa user group, and that user group is going to have backup and restore operations, authorizations, through Cloud Casa. So Cloud Casa will only see these member namespaces that are going to be involved within this tenant. Now, any changes that are being made to the capsule tenant, let's say, Dario is doing some modifications to the tenant, that is all going to be monitored and mirrored back, communicate back to Cloud Casa so that both services are in sync and we know exactly what user should have access to what resource. And this is going to be especially helpful when you are in that self-service backup and recovery phase, that if you're already using Cloud Casa, you know that you can create multiple users and group users into user groups and provide those users with their own level of access to each resource. Now it gets extended even further into that tenant namespace level, and that's going to enable your users and service providers to better manage their enterprises. So just a quick diagram here of the integration that we have here. This is the same. So on the left-hand side here is that same diagram that Dario had shown in his presentation with regards to how that capsule policy engine is isolating the different tenants and namespaces that you have out there. And what occurs is there is an add-on module that you'll install into your Kubernetes cluster that is the capsule add-on component, and that component is going to communicate back with Cloud Casa the rules of the tenancy that were created by this capsule policy engine. Those rules are going to be then correlated into different user groups, the native RBAC functionality for Cloud Casa. And with those user groups, we're going to be able to provide that level of isolation. This group can only see these namespaces, these groups can only see these namespaces, and can only back up and protect those resources accordingly, right? We don't want users to back up an entire cluster that they shouldn't have access to, and then let's say restore the namespace that hosts the payroll application or what have you. So that is the idea behind the integration with the Classics capsule module here is that both of our services are communicating, trading back and forth. So Cloud Casa is then filtering out what users can do, and if a user tries to do something that it shouldn't be doing, is not capable of doing, then it's going to be stopped by the capsule policy engine as well from a read-write perspective. And this is all part of this concept of namespace as a service, right? For self-service Kubernetes backup and recovery, you've got the high availability, the data protection, the business continuity, being able to back up persistent applications, persistent volume data that is necessary for running your business. And with this capsule integration, with this concept of tenancy, you're now able to subdivide those clusters down into their namespace parts and be able to provide access and control at that level. So just a quick comment here on Cloud Casa for Valero. So we've done several webinars already on Cloud Casa for Valero, but this is something that we've announced at KubeCon in Amsterdam just this past April here. And if you are already using Cloud Casa for Valero for your backup purposes, remember you have that freemium of 15 nodes. If you submit a basic or subscribe to a basic plan, I believe you get the 15 nodes for free, and it's a $20 per node, per worker node after that. But please do. This is something that you can, scan in your credit card to our website and subscribe to our plan. But we're constantly running promotions and have KubeCon codes. So please do reach out to us and your account manager to learn about any promotions that we're running for that time. But with Cloud Casa for Valero, you're going to have those additional features from a multi-cluster management perspective, centralized dashboard, centralized UI, real-time job monitoring, etc., in addition to just traditional backup and restore capabilities when using Valero. So it is you can sign up for a free account at any time. So it is a free sign up. With that free sign up, you're going to get, if you're licensing on Cloud Casa Pro, you're going to get 1 terabyte of storage. But if you're licensing for Cloud Casa for Valero, you're going to get 15 worker nodes entirely for free. And then you're going to be able to take advantage of the multi-tenancy aspect of that with by just simply installing the Classics module in your cluster. So with that said, do we have enough time for a demo? I think we do have 7 minutes. So let me quickly just jump into my demo here.
Yep, thanks, Martin. And while you're pulling that up, yeah, I did post a few links in the chat there for everybody. So if you do want to take a look at either setting up for the Cloud Casa demo or the Classics one, both are in the chat there as well. But if you do have any other questions while Martin's going through this, as always, please feel free to throw those up in the chat as well. Thanks.
Appreciate it. Thanks, Aaron. So this is the Cloud Casa dashboard. Again, this is a software as a service platform that you're going to be just opening up through a web browser, signing on to cloudcasa.io, which I've done. I'm logged in here as my user, Martin. I'm part of this group called development here. And what I'm going to do is just simply scan in the clusters that I want to back up and restore. So, and that's all done in the configuration tab here. I can just simply add a cluster, give it a cluster name. If I were managing Valero instance, I can slide this bar over, and that's going to provide me with an installation manifest that will install a different type of agent for my cluster here. So if I call, let's say, my cluster test here, register, this is going to provide me with a kubectl apply -f statement that's going to pull down the Cloud Casa agent into my cluster here. But I want to show you the screen here in terms of editing my cluster, because here is where we can access the access control and permissions, right? So on a per cluster basis, I can add permissions to a user or user group here. I'm going to go to a more interesting one, the cluster that I'm going to use for my demo here, called Valero Classics here. And you can see here that I have permissions added into this cluster. I have this user group called Hydro CC4V. This is actually the tenant name of Classics that I've created within the capsule, right? So that tenant is, so I have this user group has backup and restore resources. I can also provide read and write resources. I can continue to add permissions for specific users and user groups into this cluster. And now that I have those permissions, those resources, now I want to integrate with Capsule, right? So what does that look like from a Kubernetes cluster perspective, right? Capsule is going to be installed. There's going to be a control manager installed in its own separate namespace called Capsule System. I'm also going to want to add an add-on module. This add-on module is going to communicate. That's the service that's going to communicate directly with Cloud Casa. So this is feeding all the user rules and tendencies that I defined and created within my Kubernetes cluster, feeding that back to Cloud Casa. And if I look at, let's say, the namespaces I have out here, I have these 3 namespaces here, prefix with Hydro, a development, a production, staging namespace. And I'll take a look at the tenants I have configured here. I have that one tenant called Hydro-CC4V, Cloud Casa for Valero, with 3 namespaces. Those are the 3 namespaces I've added. So let's take a look at the YAML definition for these this tenant. Those 3 namespaces are added into that tenant here, and the user that has access to that tenant is my user Billy, right? So if I were to log in as user Billy, what I'm going to see is just resources for that cluster. So let's go ahead and I'll log out of, actually before I log out, let me just show you the users and user settings. So these are the users that are also created within my group. These users have already been added to those user groups. So if I the user group that it gets automatically added to as I created that tenant within Classics is this Hydro CC4V, and that's the same name as my tenant there. So what I'm going to do now is I'm just going to simply log out of my main admin user, and then I'm going to log in as my user Billy, who is not going to see every single cluster, who's not going to see every single job or namespace. What he is going to see is the cluster that he has access to, but he's not going to be able to perform all the operations that he would have if he were even an admin user, right? So I can drill down into that user. If I try to edit it, modify the permissions on it, I'm going to get an error. I don't have permission to control the orgs here. So this is a lower level user that is restricted from a Cloud Casa perspective, but also restricted from a tenancy perspective, right? So I'm not going to be able to drill down and see those namespaces when I go ahead and define my backup. And this is something that I ran into an issue with early today when trying to run through the demo, but let me see if this is working now. Okay, so it's what I should see here is basically a list of namespaces I have access to, and I think I might have restricted my user a little bit too much here, so I might want to contact with Dario with that. But what this should look like from a UI perspective is I should only be able to see access to those resources. So over here, I have a screenshot of what a working version would look like as I drill down into the namespaces. I'm only going to see those namespaces that have been filtered and provided to me by Classics at this point. And I'm only going to be able to find backup operations and restore operations for those namespaces. So in other words, I'm not going to have a backdoor into restoring other people's applications and resources, and that's the whole purpose behind multi-tenancy and namespace as a service. So with that said, I'm going to pass this back to you, Aaron, and thanks everyone for listening.
Yeah, thank you very much, Martin, and thank you, Dario, both for going through the presentations and demos. That was great on both of those. And if anybody does have any questions while we're still here for another minute or two, please feel free to throw those up in the chat. But appreciate everybody joining today. And I'll kick off the survey here in just a second. And again, for anybody that does fill that out, will be eligible for the $100 gift card. But thank you again, Martin and Dario, for your time today. And thank you all for joining. And if there's no other questions, then we'll catch everybody next week. Thanks.